Hello and welcome to this video where I will show you a step-by-step guide to creating another complete ESP32 project. In this video we will develop the code to multiplex sensors on the I2C bus. Let's take a look at what we'll be covering. The aims of this project are to demonstrate how to multiplex sensors on the I2C bus, to read the temperature and humidity values on the multiplexed AHT sensors, and to show the measured values on an OLED display. If you find this video useful, please press the like button and subscribe to the channel. These things are free for you and they really do help the channel develop. Here is a picture of my test bench setup. You can see here the temperature and humidity values from the AHT10 sensors. I am using a TCA9548A I2C bus multiplexer. The OLED shows the current ambient temperature and humidity from both sensors. The component block diagram shows how the components are wired. I am using an ESP32 OLED display, two AHT10 sensors and a TCA9548A I2C bus multiplexer. The ESP32 is the I2C master and the OLED, TCA9548A and AHT devices are slave devices. The VCC pins on the OLED, TCA9548A and AHT10 devices are wired to the 3v3 pin of the ESP32. The A0, A1 and A2 pins of the TCA9548A are tied to ground. The multiplexer reset RST pin is tied high. The SDA pins of the OLED and multiplexer are connected to D21 GPIO21 pin of ESP32. The SCL pins of the OLED and multiplexer are connected to the D22 GPIO22 pin of the ESP32. The SDA pins of the AHT10 sensors are tied to the SDA pins of channels 2 and 7. The SCL pins of the AHT10 sensors are tied to the SCL pins of channels 2 and 7. The multiplexer works by sending a command to it to select the channel to communicate with, in our case channels 2 or 7, and then sending device commands to the selected device to read the temperature and humidity values. A word about my development environment. I have developed this using an ESP32 DevKit V1 module. Please check your pinouts if you're using a different ESP32 variant. Note also that the solution presented in this video will only work with ESP-IDF version 5.1 or later. I have based this project on the code of a previous project. There is a link to that project in the description. Let's start coding this project. Open the main.c file and include the header files as shown. Create a tag for the logging and then define the ESP32 GPIO pins for the I2C bus. SDA is on GPIO21, SCL is on GPIO22. The OLED display is fixed at hex 3C and channels I'll be using on the multiplexer are 2 and 7. Now add the method I2C_init to initialize the master I2C bus using the I2C_master.h wrapper. A master bus handle is required and this is created in the call to I2C_new_master_bus. Also add the method I2C_cleanup to delete the I2C master bus. We now add the methods to initialize and interact with the OLED display. The OLED display is initialized in method OLED_init as an I2C bus slave device. The method OLED_show_vals displays the temperature and humidity values at the specified position on the OLED display. Now add a method to read the values from the AHT10 sensors and display them on the OLED display. The method AHT10_read_print selects the appropriate multiplexer channel and then reads the temperature and humidity values from the sensor on the selected channel. Finally, these values are shown on the OLED display at the specified row. In the method app_main, we add calls to the methods to initialize the I2C bus and the OLED display, along with the multiplexer and AHT10 as I2C bus slave devices. In the while loop, we read the temperature and humidity values for each sensor in turn by selecting the appropriate multiplexer channel. In the main folder, create a file AHT10.c. This is where we'll put code relating to the AHT10 sensors. Open this file and add the includes as shown. We will create the I2C.h file later. Define a tag for logging and an I2C bus slave handle. Add the method AHT_add_device, which adds the slave device to the I2C master bus. The method AHT10_init sends an initialization command to the AHT10 device on the selected multiplexer channel. Add the method AHT10_read to read the values from the AHT sensor on the selected multiplexer channel. The for loop contains error handling to make the process more robust. Finally, the red values are extracted from the raw data and returned to the caller using the provided float value pointers. In the main folder, create the file aht10.h. Add the includes and the method definitions of the aht10.c source file. Create the file I2C.h in the main folder. Add a defined for the I2C bus clock speed. In the main folder, create the file TCA9548A I2C. Add the header includes, the logging tag, and the I2C bus slave handle for the multiplexer. The method TCA9548A_add_device adds the multiplexer as an I2C bus slave to the master bus. The method TCA9548A_select_channel is used to select the multiplexer channel. Please note the channel must be selected before a device attached to the multiplexer can be interacted with. Create the file TCA9548A.h in the main folder. The includes and the method definitions of the TCA9548A.c source file. To make the new source files compile correctly, we need to modify the make file. Open the file cMakeLists.txt. Add the source files AHT10.c and TCA9548A.c. We have now completed the source code changes for this project. Now build your project and then flash it to your ESP32 device. Here are some exercises for you to try out. These exercises are intended to help you apply what you've learned and to encourage you to research solutions. I suggest you use this project as a basis and make any changes accordingly. Well, we're just about done with this tutorial. I hope that you found this video useful and that your project worked successfully. I also hope that you'll consider pressing the like button and subscribing to the channel. They really do help the channel develop. I will be posting more videos on ESP32 development regularly. If you have any specific ESP32 development project ideas you'd like me to cover, then please add them to the comments. And if you'd like access to the source code and circuit designs, then why not become a channel Patreon member? Please see the link in the description. I shall also be offering benefits for Patreon members in due course, such as tutorial sessions and workshops. Thank you for watching and bye for now.